Okay, perfect. So again, good afternoon, everybody. Thank you so much again for making the time to attend to this knowledge sharing session. Um, the intention behind this is to talk about, uh, the nature-based solutions for the built environment and the role of bio-based building materials to achieve climate resilient future. This topic itself cannot be worked in silos, as we know. That's why I would request everybody to participate, and maybe after the end of this presentation, we can set aside some time, maybe 10 minutes, to answer any questions you may have or any views, any observations that would help add more value to this topic. Okay, so let's move to my next slide. All right. So for those who haven't met me yet, my name is Pranoy Kaul, and I'm a mechanical engineer by profession at the New Delhi office. And my experience has been around built environment, especially in the MEP industry, where I have supported along a lot of building construction projects, especially related to HVAC systems, sustainable building solutions, retrofit, energy modeling, performance modeling, whole life carbon analysis, and and after understanding and getting a little bit in depth of what's really going on in the industry, it kind of drew my attention towards where we are and what's the state of our decarbonization goals and agenda. So the agenda of this presentation itself is that we'll be discussing about the state of our built environment. We will followed by certain impact pathways to decarbonization, which is recommended by the Circular Buildings Coalition. There are four impact pathways that has been recognized. Then I'll move on to the role of bio-based material, which is my product essentially. It's called Hemp and M Hempcrete interior wall claddings. Along with, I'll explain the importance of having a circularity in design and how it will improve the performance of that bio-based material. And this would be backed up with certain life cycle analysis parameters where we have conducted a cradle to grate LCA particularly. And with that informal product LCA, we were able to identify where we are in terms of our embodied carbon, which is the forefront of our topic today. We will be also talking about the performance of hempcrete and and be chiming around technical specifications related to hempcrete. Okay, so let's move to the next slide. This is a culture of caring moment that I wanted to share with everybody, as this topic is around sustainability. And as this says, that we want to adopt sustainability in our daily lives, and how can we do that? And this quote I really like that I wanted to share here is that sustainability starts with you and me, and can we make the defining difference? And these defining difference is actually not a really big difference. These are daily small things that we can do to help with that big difference. And it comes from all of us, essentially. And keeping it simple, I've thought about these 6 points that could be valuable and can be applied to our ease of our daily lives, which is, you know, first of all, it is about eat local wherever possible. Understand that food doesn't need to travel and take less energy to get to your plate. So avoid, I would say that, it would also minimize public traffic when you eat local whenever possible. Secondly, is about adopting public transportation. Talking about where our office is located, which is in New Delhi Cyber Hub, we have ample of resources such as, we have a metro rail, we have public transportation for our service. Yes, sometimes it may not be as efficient, but it is available for our use and also keeps us more independent. Um, Thirdly is recycle and upcycle. You know, Finding out creative ways in your own home, in your own domestic setup with your families, on how you can look for creative ways to reuse old things essentially. So you may have old T-shirts that is sitting around your house, and you can use that as a cleaning cloth, as well as uh, uh, understanding that old glass bottles you may have, you can use that as a watering plant. So these are the ways you can upcycle things around your house as well. And invest in Energy Star appliances. Um, Energy Star appliances are important because, as we already see, that it is often, especially for India, it's by the Bureau of Energy Efficiency, where we can, um, you can see that the star rating will actually help you to determine what product to go with as per the appliance I'm talking about. And it will overall reduce your energy consumption. And all of this also comes when you can educate your community. So help and educate your community, build that relationship. And lastly, which is more important, is about turning off the faucet. You know, if any leaks you have in your home, just by turning off the tap while you brush your teeth in the morning and before bedtime, you can save up to 30 liters of water, which is a lot, and it leads to about 760 liters a month. So these are some of the simple ways you can do to promote sustainability. So, coming down to the state of our built environment, this is sort of alarming right now, to be honest with everybody. According to the UNEP 2023 Global Status Report for Building and Construction, the building and construction sector is not on track to achieve decarbonization by 2050. Yes, it's not on track. And there is hard evidence to back this up. And out of that, 37% of total global energy related carbon emissions emitted is only by the buildings and construction sector, which is the highest emitter out of all other sectors we have. And 28% of this carbon footprint is only from operational carbon. And by operational carbon, I mean that it is your energy consumption, your building energy consumption, which is from your appliances at home, especially even in factories, data centers, railways, whatever appliances that we have that is in terms of building services is all related to operational carbon. And surprisingly, the embodied carbon can account for more than that, which is almost 50% of new projects' whole life carbon, which is again largely is being going unnoticed. And there's a hardcore evidence behind why embodied carbon is being unnoticed. And also looking into embodied carbon specifically related to building services, which is mechanical, electrical, public health, engineering, fire protection. It almost accounts for 75% of embodied carbon emissions. These embodied carbon emissions are actually emissions that is from manufacturing, transportation, installation, production. So these are all the building materials, all the materials that you are using to create the product you need that will ultimately be used as an operational carbon. And that the sum of that two is the whole life carbon. And if we look into this graph over here, as you can see on my screen, this graph is explaining about the average embodied carbon and the average operational carbon. This report was created by the Whole Life Carbon Assessments at a global stage, which is a case study done at Arup, and it primarily explains that that the construction industry has long focused on the operational carbon emissions. It's paid very less attention towards embodied carbon, and as engineers, architects, developers, planners, we'll have to embrace and we'll have to understand the importance of embodied carbon on our daily lives, and because this will result into the whole life carbon. So this particular graph itself is not too scary. This explains that this was a projected, a forecast of whole life carbon emissions, which seems to be reducing, but it's still not meeting the 2030 United Nations breakthrough goal, which was discussed in the COP26. This is also this also explains that the average greenhouse gas emissions of 40% in 2030 are apparent, with the majority of saving arising from decarbonization of the electricity grid, and net zero operational performance is not widespread in terms of recorded client commitment to renewable energy. So there is still a certain pushback around renewables, and this could be because of poor standardization, poor regulatory performances, also certain building codes that is not all up to the date, and enforcement on the policy side, which is very important. And that ultimately creates a leverage for clients, for manufacturers, for vendors to work their way around not disclosing for carbon emissions. So looking into this projection, like in the next 5 years when we're going to reach 2030, embodied carbon seems to be reducing, by almost 30% when you look into 2029 and 2030. And this is primarily because now more and more industry is being aware of the environmental product declarations. There has been momentum has been ignited, especially in the Europe's, Americas, where there are green taxonomies laws that is pushing for vendors to disclose their embodied carbon through environmental product declaration. And over here, the design teams could do better, with predicting for further emissions reduction if they're able to account for lower emissions associated with later procurement from material supply chain. So overall, you know, it is all about working together and creating that shift from the regulatory policy and making that nudge towards driving our manufacturers to improve and open their disclose their environmental product declarations, and that will help us reach our whole life carbon goal of net zero. And while understanding the state of our built environment, there are certain impact pathways that is also being observed. These impact pathways, as I mentioned, this is from the Circular Buildings Coalition Network, and these are four impact pathways that is being widely standardized. And on the graph on the right that you can see, it is also, I'm going to be explaining more about the shift of bio-based materials by 2060 and how it can actually replenish the carbon pool and reduce the atmospheric carbon. And that is the impact of the bio-based material that I'm trying to push with the help of this presentation across all of you. So talking about these four impact pathways, we need to first understand that decarbonization is realized by increasing both carbon efficiency of the supply chain of construction products and the construction sector itself. These things go hand in hand. It cannot be done in silos. And four impact pathways, well, let me come to the first one. It is building nothing. And building nothing over here essentially means that we have to challenge our stakeholders, our client, to building owners specifically, to prioritize towards renovation and repurposing over doing any new form of new construction. And this does require a system level rethinking, a systemic change which comes from the concept stage itself, and it comes all the way to design development. So that will, when we are thinking about building nothing, we have to think from the first day of the project, when we all the stakeholders are together and are creating a plan for this project. This requires transformation of existing office buildings, retrofitting MEP systems, as I talked about, and where and how we can optimize for energy efficiency. And this is all about extending that lifespan, essentially. Next point for the next impact pathway is about building efficiently. This pathway also requires choosing products with reduced carbon footprint, that can attain a higher efficiency and reduce emissions. So this sort of, if we build efficiently our projects which we are doing, we have the ability to actually reduce emissions by 260 metric tons of carbon dioxide using innovative design changes. And these innovative design changes need not to be large change. They can be small changes like having a shared space, in the residential apartments, or having vertical extensions, or construct different typologies like having a mixed use tower where we can we reimagine having an office space, a residential space, a recreational space all under one roof. So that's the example that I'm trying to explain. Then the third impact pathway is about building long term. Buildings can be more easily disassembled in the future. That should be the intent, is that designed for disassembly, which would help us reuse. If we have certain ductwork and certain diffusers, sidewall diffusers, we have certain LED lightings, we have certain facades. Can we pull them out after the end of the life of the building and reuse those building systems, those facades, those architecture elements into another project, so that we can reduce on the capex or the initial cost of a new project by having a full source or a bank of products that we can immediately plug into the project. And this is an example of reuse. This is an example of extending the value chain of circular building principle. Okay. Um, and the lastly that I wanted to explain in the pathway is about building with right materials. So when we think about building with right materials, we are thinking about whole life carbon approach. We want to reuse of any non-contaminated bio-based materials that are free of HFCs, volatile organic compounds, and these that will help us, with the potential to reduce almost 240 metric ton of CO2 by 2050, with an additional potential of 913 metric ton as a carbon sequestration or a carbon storage. And when we are talking about this primarily is pushing towards embodied carbon reduction when we are working around with right biomaterials. And examples of right biomaterials can be sustainable timber, can be hempcrete, mycelium, biomass, blue-green algae, and bamboo. So, India is not very new to all this. If we talk about our ancient architecture, we have been using this for centuries. It's time to connect the old thinking with the new projects, the old way of designing with actually seeing, how we can optimize for building performance using those systems. And that's where building with bio-based materials would be most useful. And if we see on this graph over here, which is the source of it is by the Building Materials and Climate by UNEP, it also says that the carbon pool itself right now is depleted. All the way from 1750 to 2020, there was a huge depletion of the carbon pool because of the mineral-based construction materials we have been using for so many centuries now. And this has gravely added to global warming, as we already know, the plus 1.5 degrees Celsius rise. And also, seeing that, why this carbon pool really is important to us, because carbon pool is a system that can store, release, and accumulate carbon. It is a reservoir of carbon in specific parts of Earth system. And these reservoirs are actually natural Earth systems, which is found in oceans, oceanic, Earth crust, soils, and forests. And this is a natural way of Earth to, replenish its natural resources, by sequestering carbon naturally. And if we use bio-based materials, we can actually see that there are certain levels of us to get it balanced, get those carbon pool replenished, and actually rebuild these natural earth system, so that we can reduce the overall atmospheric carbon and increase the terrestrial carbon, essentially, which is sequestration. Okay. With this thought, with this understanding, and with this impact, essentially, I wanted to move into a particular topic essentially related to cladding, which is about conscious cladding. And this is one of the examples, as I mentioned, around building with bio-based materials, which is hempcrete. So coming to my next slide, I wanted to highlight about what is conscious cladding. And for those who have visited the Arab Delhi office before, they may have already seen this logo. And this logo itself is made up of hempcrete, and I'll explain what hempcrete is, and why are we even working around with hempcrete. So at Hempenem and Hempcrete is a it's we are essentially trying to create sustainable architecture solutions, and these are essentially indoor just wall claddings that delivers. And by delivers, I mean to say in terms of thermal insulation, acoustical absorption, humidity control, as well as natural air quality improvements such as carbon sequestration. And as you see on my screen, there are certain cladding samples that are in different colors. These are all natural dye. Okay, they come in various colors like teal, golden yellow, rosewood. So the intent over here is to bring art and align it with performance to create a certain channel in terms of sustainability and promote for a greener, healthier built environment. Right. So that's the intention behind using hempcrete as a wall cladding. So with any new biomaterial we talk about or any new bio-based nature-based solution, it is very important to be absolutely transparent and actually stand up against any form of greenwashing. And we can do that by disclosing our you know uh, life cycle analysis, actually explaining what is the thought process behind having circularity in mind. And by circularity, for those who may not know, Um, we have been essentially construction industry has been following a linear economy model, which is essentially take, make, and dispose. So we use certain materials, we use it for the extent of its life, and then we ultimately throw it in the landfill. And if you are in Delhi, you will see the landfill all around us. And this is a big example of take, make, dispose, which is a linear economy. And that is something which is alarming because that's also adding to the global wastage and creating more issues related to health and human safety. And further aligning towards circularity in design. So essentially, hempcrete is a woody core of a hemp plant, which is actually cannabis, as per the scientific word. And this hemp plant is essentially, as we know, we are seeing it in markets that hemp is being widely used as in textiles, in various biofuels. There's a lot of demand for hemp now, even in medicinal use as well. What we are trying to do with the help of hemp is that we are trying to get the waste that is being produced by textiles, hemp textiles. They use a lot of hemp and there's a lot of woody core that is being discarded. What we are trying to do is we are trying to collect those hemp herds and we will process them into smaller shives which are actually this much size of pellets, the hemp pellets actually. And what we're trying to do is with those hemp pellets, we are mixing it with the lime binder to create the hempcrete cladding. This lime binder is actually what it helps with, which is the lime plaster. And when it's mixed with the woody core, which is the hemp shive, it helps with then the properties of sequestration work, the hygroscopic works, and I'll explain it further. And if we see that the lifespan of this hemp cladding essentially is around 30 years and even more, depending on the natural environment in which it's sitting. And when after the 30-year cycle, this cladding can be installed, can be uninstalled, and can be taken back. And by taken back, the mixture of the lime paste that I was telling you about, the lime binder, it can be segregated evenly and it can be bagged, which will be used as a compost back into the soil. So it will replenish the nutrients of the soil, and actually lime helps in reducing of the acidity of the soil. And with help of reduction of acidity, it will also act as a natural manure, as a natural fertilizer for creating a more regenerative landscaping. So those are the valued creations that we can make out of using bio-based materials. That's what I'm trying to explain. um, After that, taking the next step is that the end of life, again, the pure hemp products will be biodegradable and recycled if blended. So all this entire loop that we are trying to see over here is of us trying to use natural dyes, sustainable timber, lime mixtures, and actually see that how each and every sub product of this solution is in the favor of biodegradation. It's in the favor of actually putting it back in the soil to restore the earth's nutrients. And that is one of the examples of value chain under circular economy, where we are trying to constantly create loops. We're trying to extend the value chain, we're trying to extend the value creation, and help with, you know, actually seeing a sort of an impact at each stage of the life cycle. So coming down to my next slide after this. Yeah. So we had conducted a life cycle analysis to be absolutely transparent. We did an informal LCA of our cladding, which tackles about A1 to A3. And A1 to A3 is essentially the early stage of the any product, which includes material extraction, transportation to the factory, manufacturing, and that is also coined as a cradle to grave LCA. Okay, and additional stages when we look into this entire life cycle information, it consists of A, B, C, D, which also has in use, operational, energy use, end of life, and beyond the life cycle, which is the reuse, recovery, recycling, which is connected to circular economy. So whenever we are sort of working with any products, may it be specifying any materials for our MEP systems, which is building systems, we must, specify and work towards asking for a beyond the life cycle or an environmental product declaration to our vendors, so that we are absolutely clear and confident that how they are using their product to the end of life. That will help us achieve our carbon neutrality goal as well. So, why did we consider a cradle to gate? This is a very big question because, as we understand, and according to the SIPC TM65, which was a guideline published in 2021, a large proportion of embodied carbon of building services is associated with the product stage, actually, which is A1 to A3, as I mentioned. And this is only due to the fact that the majority of building service components are made of metals, electronics, plastics, and have a complex supply chain. And as we see that this product stage includes carbon emissions associated with extraction, transportation, processing of materials, and energy consumption used to manufacture the end product. And SIPC TM65 did an analysis of over 180 mechanical, electrical, plumbing health products, public health products on various databases, and it actually showed that 92% of embodied carbon is actually lies in the product stage. Hence, the importance of product stage is what we need to champion for, what we need to fight for, actually, because that's largely goes missing, and that is exactly where there is most amount of embodied carbon. It's in the product stage for building services at least. And this graph over here explains itself that 92% is in the product stage, then the remaining construction stage almost sitting at 5%, and an end of life stage is almost 3%. So if there is all this amount of embodied carbon, how come we are always focusing on operational carbon and energy efficiency? I know that is what the code is saying. That is what um, uh, you know building ECBC 2017 is asking for, but we will have to fight for it. As specifying engineers, planners, designers, policymakers, we need to fight for embodied carbon. Okay, so moving on to my next slide, we did an informal product LCA with a methodology as per ISO 14040. And the database that we looked into was EcoInvent, where we got our carbon emission factors for each of the material that we needed for our product, essentially. And by material, I say is the hemp chives, the hydrated lime mixture, sand, water, and even plywood. We needed plywood. So so we compartmentalized all of these data points into a cradle to grade LCA using the methodology and database of EcoInvent. And through that analysis, I'll be happy to share it with anybody who's more interested to learn more about it. The results came out that the cradle to gate LCA at the production stage itself for a 1 square feet tile, which is 20 mm thick. So all the values out here is for 1 square feet tile. We were getting a negative of 52 kilograms of CO2 emissions from cradle to gate production stage. And that is from A1 to A3, or negative 52 kg, which exactly means that it's carbon negative. Okay, and plus sequestration. So I wanted to share that hempcrete itself sequesters carbon, and with that sequestration rate, it was observed that it satisfies the product. It satisfies the B1 category of the product lifetime with a negative of 2.42 kg of CO2 for that 1 square feet tile again that I'm saying. So if we actually think about this and quantify it, that if I want it across the entire extent of my wall, and I'm talking about partition walls, its application can be in conference rooms, offices, any interior spaces, essentially where you have walls. Um, we can actually extend, we can actually see the impact of carbon sequestration if we have 1 square feet time multiplied by the entire extent of the wall area, which is almost, saying that we are looking at minus 55 approximately kg of CO2 emissions of total carbon emission reduction over a span of 30 years for just that 1 square feet tile. So if we can help explain our clients that if our clients have a target of, let's say, uh, having a negative 15 kilograms of CO2 emissions per square feet, they want to maintain that, then we can use nature-based solutions and help them quantify that with the help of a life cycle analysis, environmental product declarations, we can help you reach your goal, which is about meeting your carbon reduction goal with nature-based solutions. So that is the impact that we are trying to promote here. Okay, so moving on to performance, right? Because carbon is one thing, but also performance, economy, and installation, everything goes hand in hand, right? And in this day and age where construction projects are taking at full swings, and the need for retrofitting needs to be more emphasized. So when we compare this with a green plywood, which is which can be another competitor, we notice that almost 40% we were better in terms of emission reduction as opposed to green plywood. And this is again by doing a life cycle analysis and doing certain analysis in terms of thermal performance. For those who may not know about thermal conductivity is actually defined by the ability to conduct heat and electricity. So the lower the thermal conductivity, the better it is as an insulator, which in turn also reduces your heat load, overall heat load of the building. And that would make my job a lot more easier because I'm an HVAC engineer. I spend a lot of time doing heat load calculations. So if I have a really good material in my building, then I can reduce the size of my HVAC systems. That will totally, create a huge impact in terms of space planning, in terms of selections of my cooling coil, heating coil, filtrations, fan motors, all these things. You see the ripple effect. It gets larger and larger essentially. So having that good thermal conductivity value becomes a factor for us to have a more simple system, HVAC system essentially. And also looking into the sound reduction. These 1 square feet claddings almost have the ability to reduce and maintain about 40 decibel levels of sound reduction index. And if we look into, as per the LEED standards, around anything around 35 decibels is considered to be pleasant to the ears, essentially. So having 25 to 30 dB, 35 dB is considered to be good. And so hence that is exactly where we can say that, okay, where can we, with the help of our acoustic consultant, with the help of certain analysis, we can figure out how we can optimize these levels to meet the nature of the room requirements essentially. And Well, last but not the least, this is a technical product specification of that 1 square feet tile, which I was telling you about. These just to wind it down, the this is essentially trying to explain that which is important to notice is that hempcrete itself is very porous in nature, and due to its hygroscopic properties, it is able to balance excessive vapor in the atmosphere and in the local environment in which it's sitting. Because of its 70 to 85% porosity, it can capture and store vapors within the product. And similarly, looking into the fire conditions, um, uh, the it is class B fire rated, which actually means that class B S1D0 essentially is a fire rating class, which is mentioned in the British standards, which is in the BS standard. And even IS 12777 is Indian standard, which talks about fire ratings essentially. So this product itself has a really good fire rating. The ability for flame spread and smoke spread is very less because of its densely packed structure that it has, which I told you, which is composed of the lime mixture and the hemp. So because of the densely packed structure with the heavy volume density, the fire propagation rate is far lower, which will help increase, in an event of fire. We have fire rated walls, but if we have additional architectural elements that can reduce or retard the fire, it will help for a safer evacuation, for example, right? And this is pretty much it. Like this sort of understanding, why I today wanted to explain where we are in decarbonization. What is the state of our built environment? How we can break it down into four impact pathways that I just mentioned, and then primarily pondering and explaining the value of embracing nature-based solution into our building projects, we can really make an impact to reduce on the embodied carbon. And with that note, I would like to thank each and every one of you for taking your time to participate on this session. And if you have any questions, I'm happy to take it up now. Thank you so much. So does anybody have any observations, any thoughts, any sort of interesting projects you have worked on that may have required using bio-based materials? We can talk about it. Looks like a awfully quiet group. So I'll do one thing. I will try to explain that if there is no other questions, then I will be happy to close this meeting. And again, if you have any questions, you're curious about how we can use nature-based solutions in our building projects, feel free to reach out to me.
Thanks, Pranay. Really insightful presentation.
Thank you, Kevi. Okay, thank you so much for your time then. Talk soon. Thanks. Bye.
Bye. Thanks.
Okay, thank you. Bye-bye.
Thank you.
Thank you.